Hello, everyone. Thank you so much for joining us today for our fireside chat on evaluating workloads. Is Postgres the right fit? I'm your host, Annie. For this session, we have two fantastic speakers. First, we are honored to welcome Marc Linster, former CTO at EDB, as our guest speaker. Joining Marc in today's conversation is Umair Shahid, the founder at Stormatics. Together, both speakers are going to explore some of the most common questions and important questions that teams have been asking when working with Postgres or starting to work with Postgres, including what are the biggest challenges developers are facing, or whether Postgres is evolving to support things like analytics and AI, where it might not be the right fit, and what's ahead in Postgres 18. And while I'm talking about what's the agenda for today, I will plug it in over here that Stormatics is proud to be an EDB strategic partner. And we are super excited to have this conversation today with Marc. So before we begin and I hand over the controls to both the speakers, I just want to give a quick overview over the housekeeping related agenda. So the session is being recorded and we are going to share the recording afterwards with all the registrants. Feel free to submit your questions in the Q&A box or in the webinar chat box, and we'll address them at the end of the session. And that's all from my end. Over to you, Marc and Umair.
Thank you, Annie.
Thank you, Annie, and welcome, Marc. I am, if it's possible, even more excited than Annie to have you here.
No, this is good. It's good.
I really appreciate you joining us today. And with the extensive experience and exposure that you have had with the Postgres community, and not just the exposure, the influence you've had, I think that your insights into the evolution and where Postgres is headed is absolutely valuable. I hope the audience is going to enjoy this conversation as much as I am looking forward to it. So
thank you. And I just came back from Postgres Day France, which was yesterday and the day before yesterday, and also great attendance and lots of the topics that we're going to discuss today were also important topics there. So good.
Excellent. So just kind of spinning off from how I said that you've been around the Postgres community for a long time. I think it's been a decade and a half or something.
13 years. Yeah. Mm-hmm.
Yeah. I'm sure that you've seen a certain evolution of Postgres, not only in the way the technology has evolved, but also how the technology has been is perceived in the industry. Compared to, let's say, 15 years ago, tell me about your impressions. Tell me how you think people saw Postgres when you started off, and how people see Postgres today.
Well, I tell you a personal anecdote. When I went to the first Gartner Summit, I think in 2012 or 2013, together with Ed Boyajian, who was at the time the CEO of Enterprise DB, we had to tell people what Postgres was. Postgres, Progress, Progress software, Progress database. There was a lot of confusion. Very, very few people knew Postgres, right? So the mission at the time was to evangelize for Postgres. Well, that's completely changed. Today, everybody's using Postgres. The question is much more, how far can you push it? Or can you help me figure out, how far I can push it in my stack, how mission critical, how tier 1, tier 0 applications can be supported that way. And then now recently, how does it help me with new modern applications that have a different architecture, that are microservices focused, that don't just differentiate between transactional analytics and AI, but applications that do all three things together, right? Do them at the same time. I mean, think about a shop floor control system. It also drives reporting panels over every manufacturing line where you can see at any moment in time the number of failures, the throughput, everything. So transactions and analytics is the same thing today. And Postgres is extremely well positioned to do that. So to your question, 12, 13 years ago when I got started with Postgres, the question was really much more, what is it? But now it is really just how far can I push it, and how fast can I get onto Postgres.
So that's a very strong indicator, or a strong statement, I would say, that going from having to tell people what Postgres is to the point where you kind of take it for granted that everybody knows Postgres. It's just about how far you can push it. That's a pretty big evolution. And there have been surveys out there that kind of track some of that popularity, and especially with application developers. Maybe based on what you have observed with application developers and over the period of the last 5-6 years, you can share some of those insights of how you've seen that evolve.
Yeah. Yes, absolutely. And you always have to understand there's a certain lag between what developers do and what executives know, right? And a lot of my conversations were at the executive level. So today, at the executive level, Postgres is a thing. Now, interesting enough, it's not really a topic of conversation because it just works, right? And economically, it's very, very interesting. So why should a CIO, CTO talk much about it? Because it doesn't cause problems. It doesn't make the phone ring in the middle of the night. It just works, and it's a very economically interesting alternative to commercial products. But when you look at that evolution, let's say over the last 6 years, and I think the data that you're referring to is the Stack Overflow survey, where 6 years ago, we're now 6.5 years ago, when they did the survey in 2018, about 30% of developers reported using Postgres. And every year that has inched up. I think in 2023, it was for the first time #1 over MySQL, SQL Server, etc. And by the way, things like Mongo that a lot of people talk about are like far down the list. They're in the long tail, actually, even though they get a lot of press and a lot of commercial success. But from a developer usage perspective, the top players were always, MySQL, Postgres, SQL Server, Oracle. But when you look at the evolution from 32% usage in 2018 now to 51% in the 2024 survey. So not just is it the one that is used most, it's actually the majority of usage now. So, and that is really radical, because you have to think about that developers also maintain legacy. They don't just do new stuff. So in there, you have to factor in that probably, I don't know, half of that 2/3 of the world's IT effort goes into maintaining stuff. A lot of that stuff was built on MySQL and SQL Server and Oracle, etc. But still, that percentage is pushing really, really hard. To me, that means that in the innovation space, so where we do new stuff, not maintaining stuff, the usage of Postgres is probably even much, much higher, in probably 70, 80%, if not more. The rest is maintaining stuff that was done 5 or 10 years ago. That's something that we shouldn't forget about. These statistics don't describe the whole picture.
That's a very interesting insight. I mean, there's this data that's kind of lurking behind the data. That, you look at the overall usage, but that overall usage kind of contains the legacy systems as well. And if you look at greenfield applications, new applications, Postgres probably comes in at a very high, a lot higher percentage.
Correct.
Let me digress a little bit. I mean, we've been seeing reports now about how forums like Stack Overflow are seeing reduced traffic, and maybe developers are no longer that involved in Stack Overflow. They're more involved with some of these LLMs and AI agents, and asking questions from ChatGPT. Do you think these numbers are tainted in some way because of that shift, or a pattern shift?
I don't know. I don't think the numbers that we now talked about are tainted, because we were talking about data collected in 2024, when the hype or craze towards ChatGPT and DeepSeek and others was not as strong yet. I'm personally very, very concerned because I often use things like, I personally like DeepSeek. So digging into them, but I find a lot of garbage answers. I find a lot of wrong stuff. And what's interesting is many of the good engines give you a link to where the sources were. When you follow them, kind of scratch your head, say, where's this garbage coming from? And there's too much of that stuff out there that was also generated by AI, generated as marketing fodder, as SEO fodder, right? And so my big concern about it is that things are overhyped. News get picked up that aren't completely cooked, and then they turn into articles. I mean, I found an article where one of the LLMs was convinced that in Postgres 18 we had DDL replication as part of logical replication. I was saying, wow, I've heard that. So I dug through that, and the article that this was based on, fortunately, was linked, but the article is garbage, right? I also called a couple of people, and then they told me, yeah, there were discussions about it, but it definitely didn't happen. So I would be very, very worried if people move away from Stack Overflow. I mean, they are moving away, and I'm concerned about it for two reasons. Not just the quality of the answers. I mean, the good thing about things like Stack Overflow is there are humans in the loop, solutions get upvoted, they get approved. You know that they're pretty good. And if they're not, somebody is really going to call it out. Okay. Whereas with AI, it's sometimes making a very, very strong statement, and it's just old stuff. I was looking up some code for unique identifiers in Postgres when I was developing materials for a class, and with great conviction, I was told, "Well, you use serialized." I thought, didn't I read something about that? Well, serialized was deprecated now 7 years ago. So it's still supported, but it's not the way to go. It's a big security risk when you use it instead of doing it the new SQL standard way. So I'm concerned because of the quality, but I'm also concerned because these engines feed off the existing data. So if there are no new answers published on Stack Overflow, the quality of the answers of these engines will go down because they feed on stuff that authors put out there. And if that stuff doesn't exist anymore, well, we're going to see a decrease in actual support for new features.
Yeah, that certainly is very concerning, and it's kind of like disinformation promoting disinformation, or in harsher words, garbage feeds garbage.
Yeah.
You got to be very, very careful around that. But as I said, we're probably digressing. Let's get back. You had mentioned modern applications, and you made a very interesting point about transactions and analytics kind of going hand in hand. Let's dive a little bit more into that. Maybe lay out some of the challenges that you've seen in modern applications, and what kind of demands these applications are putting into the database.
Yeah, I mean, the one side it is the closer connection between transactions and analytics, right? That analytics isn't the way I knew it when I started in IT, where the data warehouse got loaded over the weekend, and then if you were lucky, you had last week's data to do some analysis and reports, etc. Today, we don't want that anymore. We don't want data that is a week old. We want to be much, much more reactive and faster moving. So the closer we can bring these two things together, the more productive we become. There are retail sites today that recalculate their prices all the time, right? Well, if you can't say, hey, is this stuff flying off my shelf? Oh, this is moving slower than I thought. So if you can't do that right now, well, then you lost 24 hours, right? And that's not a good thing. So transactions and analytics are coming much, much closer together. And we see that in capabilities in Postgres. On the one side, when I started with Postgres, when we were looking for a customer reference of, let's say, a terabyte of data in 2012, 13, 14, that was really hard. And then the boundary shifted to 5 terabytes. Today, I know about companies that have way over 100 terabytes in a single instance Postgres database. So this frontier where we thought we could only have like the currently active data in Postgres, for the rest you can't handle it anymore, that's already been pushed away. So we can now handle the volumes of data in Postgres that you need to do analytics. At the same time, you see inside Postgres capabilities developing. I mean, we have materialized views. Now there is an extension that helps us refresh those materialized views in the background. We see powerful things like materialized CTEs, window functions, roll-ups, cubes, all that stuff is there. So whereas, 10, 15, 20 years ago, you had to go to a specialized product that could do OLAP. Well, there may still be situations where you do need to do that, but they're a lot less important than they were, let's say, 10, 15, or 20 years ago, where you had to go there with already a relatively small data set. Today, if you're a Facebook-like company, sure, you can't put all that data and analyze all that data in Postgres. But for a large percentage of current analytic and transactional applications, you can actually do that in Postgres, not necessarily in the same instance, but with the same technology, the same skill set, the same DBA cookbook, the same everything, right? So that's a huge advantage. And now we see the third side of that modern application, which is AI. I mean, I know there are specialized AI databases out there, right?
Yeah.
Yeah. And so, and they have a justification, like Weaviate and Pinecone and others. But we're also seeing that PG Vector is actually really, really good. And so we're seeing that now, instead of having to spin up yet another database, you can actually do that inside, not necessarily the same instance, but with the same technology. Same thing that we saw with Mongo, right? When Mongo and documents came out, everybody thought, oh, wow, if I want to do rapid development where I don't need a DBA in the cycle and I can just make new data fields, I have to go to Mongo. It didn't take long. And Postgres had the same capability. And some people even say better, faster under certain use cases and workloads than Mongo. So are there still specialty use cases where you get a lot of mileage out of the specialty databases? Absolutely. But the price that you pay by having multiple databases that you need to keep in sync through data pipelines, that you need to back up and recover and have DBAs and developers trained for them, that price is very, very high. So we see a lot of convergence with the modern applications towards one platform like Postgres. In my view, it's one of the reasons why Postgres is so strong, because it has this object relational architecture that makes it possible to have extensions like GIS, like JSON, like PG Vector, but at the same time, still have the same management and maintenance framework.
Right. And just, if you allow me to add one critical aspect that I feel that sometimes we've seen in our customers that kind of overlook when they're looking at multiple technologies in the same workspace. It's also about the security, about the patching, about the CVEs that pop up every now and then. You have to maintain all of these different technologies rather than just focus on one and making sure that is, a kind of watertight.
Yeah. So you're absolutely right. I mean, if you're a major enterprise today, and I've worked with quite a few of them. I mean, I know one, my probably favorite customer, they called me and said, we had a 6-second outage, Mark. If that happens again, you guys are out. Well, okay, we figured it out. It was not Postgres. It was actually something else. And everybody moved on happy because we figured out how to make the problem go away. But imagine you have 6 or 7 different database technologies. If they're all at 3 nines, 4 nines, 5 nines, well, if they're all together, you actually multiply this and you're really rapidly dropping in your high availability. That's one thing. The other thing is, if they're running on the same database technology, your DBA in the operating center at 3 o'clock in the morning, when there's an issue, pulls out one folder and says, oh, this is the error message. This is what I do. Okay. Imagine there's 4 database technologies.
You don't know
How
where
are
to
you
look.
going to do that?
Yeah.
You don't know where to look. You don't know how to train. You can have 4 people sitting there, the expert for this, the expert for that. No, you don't want that. It's just not affordable, right? It may increase the initial development speed, but we know that 3/4 of the cost of ownership of an application is maintenance and operations. So it's really worth it to use one single technology like Postgres to minimize this maintenance and overhead that comes later.
Right. So I'm going to double click on the AI aspect that you mentioned. And one of the biggest news that came out this week was the acquisition of Crunchy Data by Snowflake. And the positioning has been, enterprise AI Postgres. Right? So maybe share some thoughts about that. And, how do you see AI and enterprise and Postgres kind of coming together?
Well, I mean, first, it's a huge success for Postgres, right? I mean, for anybody who's worked on pushing Postgres forward, the Postgres core team, the contributors, but also the evangelists and the people using it. This is a huge success, a huge endorsement of work that was done over the last 30, well, actually 40 years. Okay, so that's the first thing that we need to say. This is really like the major new database companies saying, yep, we cannot go forward without Postgres capabilities. So that's fantastic, right? And that shows that the numbers that we talked about before from the developers, that they were right. It's not just developer pipe dream. This is actually where the market is going and the capabilities that enterprises want. That's why we have these, I think, very successful acquisitions for significant numbers that are being talked about. So that's one thing. The second thing is that what we're seeing is the realization of what we talked about before, that transactions and analytics happen in the same environment and what's really important in the same language, right? I mean, they had already all pivoted towards a form of SQL, but it wasn't necessarily standard ISO SQL.
Yep.
Okay, so it made it more difficult for developers, for maintenance, for management tools, etc. And I believe that part of the motivation here is to say, I will have all these services of my platform, AI, analytics, and transactions, all accessible through one platform, one query language, right? And imagine what is possible then if you make that platform layer smart enough to say, oh, I know this is a query for AI, this is a query for this is a query for that, right? The service and the value that you can provide. But it's all running through a Postgres interface. And by the way, this is not new. Cockroach and LOIDB and Gigabyte, they'd already shown the way that the market wants the Postgres standard SQL interface, even if the engines behind the scene may be a little different.
Yeah. And just kind of this was just this week and very fresh in my mind. That's why I brought this up. But just rewind back a couple of weeks, you got the Neon acquisition by Databricks. So the same, kind of I get the same story where Postgres is attractive to all of these organizations that are handling data in some shape or form.
Yeah, absolutely. I mean, whether this was, I have a hard time imagining that this deal was just put together in 2 weeks, so that it was just FOMO. I think this was probably prepared for quite a while and just a necessity because the market is asking for it, right?
Yep.
But it is really interesting that 2 players with slightly different perspectives on Postgres got acquired that way by two competitors in the analytics and AI space.
Yeah, no, I'm sure that this has been going on. Something like this doesn't happen in 2 weeks. It takes a long time. Yeah. Let's talk about. I was actually reading just earlier today that I think the number was 89% of the world's data is unstructured, and it needs to be stored somewhere. It was something, I forget the number, but it was definitely over 80%. And Postgres has evolved a lot of different ways to handle unstructured data and do so really well. Maybe talk about that a little bit as well.
Well, think about, I mean, the very first unstructured data, I think handled by Postgres was text data, right? So trigram, I think, was the very first, but more advanced way of searching text. TS vector came after that, and now we're seeing other interesting developments. Let's say you look at PG vector for working with unstructured data, right? Where you use some LLM to create embeddings. You store the embeddings in Postgres, but you don't necessarily store the unstructured data. You index it, you know where it is, you know how to get to it, but you have the database or the semantic content of that in Postgres, but you leave the rest of the stuff in S3 or some cost-effective object store, right? And I think we're seeing similar things with extensions, Crunchy Head, Crunchy Base. We see DuckDB, we see ParadeDB, we see a number of ways of how what was considered to be like a hard wall just gets breached, and Postgres learns how to work with this large amount of data without necessarily saying all that large amount of data needs to be stored as Postgres tables and columns, which would be folly, right? So I think we're seeing the scope expand significantly, and there's a number of vendors. I think EDB is one of them, who are also going after integrating that data under one coherent interface where you can ask a question in Postgres language, but that question ties into tables, into documents, into pictures, etc., to all answer it at the same time.
So let me ask you, a slightly different question in your opinion on how this happens. You said that Postgres evolves to do this and this and this, and it does it better than the specialized databases eventually. There are other open source databases out there as well. What makes Postgres so different that this technology is able to adopt and absorb all of these different demands that are coming in from modern applications?
I think there were some genius decisions that Mike Stonebreaker and team took many, many years ago by saying this is going to be an object relational design that is inherently extensible. Okay, but that was a long time ago. Then, magic happened when the Postgres community was created, and the people who ran the community, helped create the community, created something where today we have, and I'm probably forgetting quite a few. We have Microsoft, Fujitsu, NTT, Enterprise DB, Stormatics, VMware, you name it. Like there's like dozens of companies that collaborate on this. So the drive is tremendous to do this, and the amount of talent that is coming together in this completely open source project is fantastic. And I was an engineering manager for many, many years, also in proprietary spaces. This amount of talent that Postgres is able to put to the task is just phenomenal, right? That's one thing. The second thing is people only work on the stuff that they need, meaning there is no product management. There's no marketing. There's nobody telling anybody what to do. They only work on things that solve problems that they have. Okay? So, which basically means there is no developing features to beat anybody. There's no competitive situation. There's an entire focus on solving this problem. I don't think anybody working specifically on Postgres is trying to develop a feature because they need to beat Oracle or SQL Server or MySQL. They do it because they have a problem that they need to make go away. So the focus of, the energy and the way this energy is focused is unparalleled. I've not seen anything like that anywhere. And now you look at other, let's say, open source database projects. Look at MySQL, look at Maria, look at Mongo. They're good things, right? And they're not bad products or anything like that, but they're all mostly single company efforts. So this enormous amount of juice and energy that comes because lots of companies are not competing, but collaborating to do something really, really interesting, that's not there. And that's why I think Postgres has been outrunning almost anybody else in terms of innovation and quality.
And yeah, I think, even in the open source space, in the open source world in general, not just databases, Postgres community tends to be a little unique in the way that it is structured. And I am frequently asked the question, what if Postgres is bought out by some company? And I typically say, there is nothing to buy. What are they going to buy? Right? It's not a company, it's not an LLC, it's not a corporation to buy. Right?
And nobody has assigned their copyright.
Yep.
Important. So yeah, there is not a thing there. And then Postgres has its own codes where it says no company can represent the majority of the decision-making, say, framework in Postgres. So no company can have the majority. No company can actually take control of it. And I think that's very important. So that's why I'm saying there was the technical decisions that Mike Stonebreaker and team took, but then there is a real community magic that is happening there. And it's amazing how, competitors in the market cooperate or collaborate on the code, but they compete in the market. But they still realize something that has become the number one database in cloud and on-prem, and is just driving innovation like nobody else.
My next question was going to be about the cloud. So I'm glad that you brought that up.
Mm-hmm.
Let's talk about that a little bit, and especially with the hyperscalers, each of them have their own offering for database as a service. Postgres is right up there, and not just the hyperscaler. Pretty much any cloud provider that you have across the world has Postgres in some shape or form. Maybe double click on that a little bit, and also how were they able to adapt and adopt Postgres so quickly and so extensively?
Well, first, yes, you're right. Postgres is everywhere. It's not just on-prem everywhere. It's in every cloud. Just on this Postgres Day in France, we talked about OVH Cloud. We talked about Ivan. We talked about a number of smaller cloud providers. So it's not just the really big ones. It's everybody's doing it, right? How did they get there? Well, you may remember the article a long time ago where the cloud service providers were accused of strip mining open source. Well, what's really interesting is when you look at what Google, Azure, and Amazon are doing, Amazon has built a really large team around Postgres. And not just people who kind of put Postgres to use, it's actually people who work on the Postgres project and make Postgres better, right? People like Andreas Freund work for Microsoft, and they make Postgres better and significantly better. Now, given some of the things that they're pushing for, are things that makes Postgres better in the cloud, right? But that's okay. Okay, so I think, at least as far as Postgres goes, I don't think that it is true that anymore that you can say that CSPs are strip mining open source. They have put large teams together. They have bought open source Postgres companies, right? And they are fully committed to it. So it's one of the few areas where the conflict between the open source community and the CSPs does not exist, at least not in the form that we had it with, let's say, Elastic or Mongo or others, where they chose to change their license to protect themselves.
Yeah.
But that was also because they were largely captive open source communities or single company open source communities. And Postgres is very fortunate that so much of the actual contribution today comes from the cloud service providers.
And I think that plays into the point you made earlier as well. If the cloud providers are pushing for features that make Postgres more friendly to the cloud, they are solving a problem that they face, right?
Yeah,
and that is what
exactly.
everybody is doing in the community anyways. There's no,
Yeah.
central authority in some way. So it plays into the same thing. And it actually, ends up making the product better all around.
Yes, exactly.
Um, Maybe talk about the Postgres license for a little bit. I usually tell people how liberal it is, pretty much as liberal as it gets. Do you think that is one of the factors, at least, that encourages the adoption and use? Do people even
I
care?
think so. Will they care? Because what's really funny is sometimes we get questions from large companies from the procurement department saying, "What is the license? This can't be. I've never seen this." Right? So it takes some work. And I know I worked much with Bruce Momgen, and he had to do some convincing that indeed that was it. If you want to contribute, contribute. You don't need to sign anything. You're not signing your rights away. Nothing. It's just completely permissive. And I believe that has contributed significantly to the success because it is so easy to get involved. It doesn't mean anything if you install it. If you write an app that uses Postgres that runs on your mobile phone, you don't need to worry about any kind of copyleft or anything that could harm you. So, which basically means from an agility perspective in the development process, probably one of the best things you can do because there are no strings attached. So just take it and move. And the 6 weeks or 8 weeks that you would otherwise spend in legal review, well, you already got half your app done by that time.
Yep. I like to put it this way. The license is a grand total of 143 words, and it essentially says two things, right? It says, do whatever you want, and don't blame the University of California if something goes wrong.
Exactly.
That's a complete
Exactly.
license. Right?
Mm-hmm. Yeah.
Let's talk about the developer experience and the tooling around, that's available for developers and makes it easy for them to adopt the database without needing experts or DBAs to come in.
Yeah, I mean, there's tools in different areas, right? So I have the tool for the people who install and support the database. I think their cloud native Postgres is one of the really interesting things. So as we see the world move towards Kubernetes, that is cloud native Postgres is really the way to go with a good operator, etc. It really makes life a lot easier. But then there's also tooling for the developer themselves. I mean, obviously PG Admin has been around for a long time as a really good tooling. But I've just heard that Visual Studio or VS Code also has a strong Postgres support that was just recently re-released and gets very positive support. So I think there's a lot of tooling. There's a lot of tooling also around monitoring and trying to debug things, etc. The tooling area is still an area where I would say the open source is not as mature. Meaning there are a lot of good tools out there, but it's an area where I think users will benefit from working with somebody like Stormatics to say, hey, here is the universe of tools that you need to do installation, incremental backup, replication, high availability, but then also schema design, code development, etc. Because that space is very fractured as far as the open source space goes. So they're putting something together that is consistent and coherent and works together and survives the next upgrade. Is an area where I think services company or specialized Postgres companies like Stormatics can really help.
Let's talk about the workloads. Transactional workloads is something that Postgres has always been good at and known for. Maybe talk about the enhancements that you have seen built into Postgres for analytical workloads and how it is increasingly getting better with that.
Yeah, well, so I think there's a couple of things. There's things that are happening natively inside Postgres, like the materialized view, like rollup and cube, analytics functions like the Windows function, CTEs, etc. Right? That's one thing, and there's been a lot of work there. These things perform really, really well, and partitioning, and parallel query, and things that 10 years ago we didn't have, and they were a big drawback, especially for any kind of analytics questions. Okay, they're there now, and so there's a lot of work that can be done that way. Then you have add-ons and extensions to Postgres. Like I just saw the release of Warehouse PG, which is basically Greenplum, brought back to life under an open source license with a Postgres friendly interface, right? We all know that was based originally on an older version of Postgres. It has been brought forward now to more recent releases. So that's basically speaking Postgres. And you can do with that petabyte solutions, right? You can get commercial support from vendors like Broadcom or Enterprise DB for this. But then you also have the extensions like DuckDB, ParadeDB, etc. that open up Postgres towards the unstructured data. So and what's really important is the open data formats. So Apache open data formats can now be processed through a Postgres interface. So there's a whole lot of stuff happening there that I think is really, really interesting.
Got it. And, so we talked about transactional, that was always there, analytics, and the other workload that is fast gaining momentum is, well, AI, the buzzword. We've already spoken a little bit about PG Vector, that's storage. What other features or extensions or tooling you've seen pop up in the Postgres ecosystem that support the AI development?
Well, I mean, Madlib is like anybody who works with R as an analytics function, something that you can use with Postgres. I mean, R has always been, not always, but been supported in Postgres for a long, long time. PL Python, PLR. So basically, that means to the folks who are not really into Postgres, that means versions of Python and R that run inside the database. So they run inside a stored procedure. And what's really interesting for that is that the processing happens right next to where the data is. So you don't need to stream it to another server or anything like that. You bring the code to where the data is as a super efficient way of doing it. So you can do quite complex Python operations right inside the database, right next to the data. That's really, really interesting. Yes, we have PG Vector then as the headline grabber, but there's been a lot of work in that space for a long time.
Got it. So we have spoken a lot about what has come into Postgres, but Postgres 18 beta is now out, and it's always an exciting time because now we know what features are going to make it when it becomes GA, probably somewhere in the September-October timeframe. maybe talk to us about a little bit about the features that you're excited about that you see coming up in version 18.
There's a lot of, there's a long list of performance enhancements that I don't really want to get into the detail, but it's like all over the place. People are honing, tuning, making things faster. So that's exciting. That's exciting every single time. Then something that's maybe a little pedestrian, but the way to understand why Postgres may be slow with some queries, the explain tool is going to be significantly enhanced by also giving us visibility into IO usage, CPU usage, wall data production, etc., right? Which has always been an issue. So we're going to have much better tools to understand what's going on there. Then there's maybe one more administrative thing, which is the OAuth login, right? So that we can tie Postgres into into security environments in a more transparent and easier way, right? So OAuth, I think, is where the world is going. LDAP was always supported, Kerberos was supported, but that's more difficult. OAuth is the way to go. So we'll have OAuth support. Async IO looks really, really promising for a lot of workloads. Significant throughput support. And then something that's just me geeky, UUID v7. And for those that don't know what that means, it's basically UUIDs are guaranteed unique IDs that you can use in distributed databases to make sure that, if Umair was a server and I'm a server and we both accept e-commerce transactions, that they have unique IDs that they can be kept separate. UUIDs were guaranteed unique, and they were the best we had for a long time. With UUID v7, they are guaranteed unique, but also sequential. So for a database that stores data or stores IoT data, so machine data, these are like fantastic performance enhancements, and they make data modeling a lot easier. So there's a lot of really interesting stuff in Postgres 18, and I'm really looking forward to being able to put it in production.
That does sound very exciting. Now, we've spent a lot of time talking about how Postgres is good for so many things. Maybe, let's spend a few minutes talking about where you might recommend that, hey, you know what, let's not use Postgres here. Are there workloads or scenarios and situations where you say that let's not use Postgres here?
Yeah, I think there are. And so the way I'm looking at it, think about a continuum that starts with a mobile device, okay, and goes all the way to, like a really huge data lake with multiple petabytes of data, okay, and data coming in at fantastic speeds. In the middle, where the majority of the work is happening, that's where Postgres is really strong. To put stuff on, if you need a database for a mobile device, SQLite is probably the way to go, because you don't need concurrency control. You don't need all those things. And even though Postgres is very, very lightweight and could probably do it, there may be better choices. Okay. On the other side, the same thing for the super large data lake, super high ingestion speeds, etc. Postgres is at its nature, and internally it's a transactional engine, right? It is an engine that wants to control foreign key relationships, wants to control consistency. Well, if you don't need that, if you just have thousands of thermostats spewing data at you, and you're not going to do anything like consistency, and if you lose every millionth row, it's okay. You don't use Postgres for something like that. That's my feeling. Now I know there's probably a lot of people in the audience who say, "How dare you? How dare you? I can do it." But yes, and there are people who I know can do stuff like that. It's just like the people who have I think it's 250 terabytes Postgres database that's actually used for credit card payment processing. So it's super high performance. But there's only a few individuals in the world who can do that today, right? But there is there's the central part of this range where I would say 90% of all IT activity happens. That's where Postgres plays. Left and right of that, there are specialty players who I would think are better suited for those tasks.
Got it. Really appreciate you sharing the perspective. We are coming up on the hour that's allocated, and I think that we should probably take a few questions from the audience now. Maybe there are. Annie, do we have something from the audience that we should talk about? I mean,
Yeah, we
Mark and I
do.
can probably go on and on, but
No, I'm glad you put a hard stop to your discussion because then I was going to be like, excuse me, we have questions. So yes, we do have a few questions from the audience, starting with the first one. What are the main limitations of Postgres when dealing with high ingest or real-time data?
Well, I mean, high ingest. I would say use Postgres if you actually want to do something with that data. Meaning, if you want to look and say, is this data actually coming from a thermostat that I know? Does it have the right units of measure, etc. Right? So in that case, Postgres is quite good, right? And you can use Kafka or NiFi as a way to get the data into Postgres quite efficiently. You have extensions to Postgres like Timescale DB, who are specially built for that to accept append-only data in very high volumes. So there are ways of doing this, but again, if you have a very high volume, I would say go talk to our friends at Timescale DB because they are specialized. If your volume is somewhere in between, there's an open source version of Timescale, and then I think Umair and his team can help you set that up and make sure that it works for you.
Thank you, Mark.
Yeah, just to if you Ali, allow me to just to build on that, I think that the key point, Mark, that you pointed out here was if you plan to use the data, right? Because I think that's one of the things that I find missing when you talk to customers. That the push is to ingest data as quickly as possible, and hence you need this specialized technology. And the question to ask is, well, what do you do once you have ingested the data? What do you do with it?
Yeah.
Oh, we're going to move it to a relational database and then analyze it and then do something with it. Well, how about you just ingest it in that database in the first place?
Yeah.
Right.
Also for cost reasons, right? Because if all you do is ingest the data, you put it on S3 or an object store, right? And an object store is multiple times cheaper than an SSD that you would use for Postgres. It's the differences are crazy. So yes, if all you want is ingest the data, put it into a data lake, right? Structure it a little bit, make sure the data lake doesn't turn into a data cesspool, but you don't need to put it immediately into a relational structure.
Got it.
Okay, moving on to the next question. Which feature in Postgres 18 should influence architectural planning today, in your opinion?
So when we say architecture would include data model design, then look at what the UUID v7 can do for you. Because I'll just take 10 seconds to explain that. UUID v7 has a very large timestamp and a little random number, or still a big random number, but they stay in order. So if you use UUID v7, you can do partitioning on this primary key, and it will always be in the right order. So cutting off a partition or dropping a partition or working with these partitions is significantly easier than what we had before. So that is certainly something that I would consider as something that drives architectural decisions. Also, the copy command between servers has become much more efficient, so you can do something. You may be able to do things that before that were more problematic.
Okay.
If I can ask you a follow-up question,
Yeah.
Mark, on this GUID v7, there's always this question about multi-active, multi-write architectures. And I think 17 came in with this enhancement about origin information within logical replication, which now prevents cyclic replication. Does this GUID v7 help in any way in multi-write kind of structures?
Probably, because the indexing becomes much easier, right? Because I mean, if we use it for primary key, that will always have a B tree index, and because UUID v7 is let's say pre-sorted for the timestamp, the creation and maintenance of the indexes will become much easier and much more effective. So back to your question, what happened? How does that support a truly distributed solution? Well, it will become a good bit easier because we actually know what happened first on which server. So merging data is likely going to become easier.
Got it.
Okay.
Thank you.
Thank you. Moving on to the next question. How should teams evaluate whether to build on native Postgres versus a managed service or simply just fork it?
Don't fork it. I mean, don't fork it. I mean, there are a couple of companies out there, mostly that I know of in very large financial institutions that have a reputation for very solid internal engineering. But these people have like hundreds, if not thousands, of engineers working on this, right? Then you can think about it. The problem is when you fork it, you own it. If it breaks, if you lose, if it eats your data, you own it. There's nobody who can help you, right? Whether you should go with a managed distribution or manage your own, again, it depends on, do you have the skill set and do you want to allocate the resources to that, right? It's like, I mean, there's also compliance concerns, but if you want to run it yourself, you need to have the skill set and the resources to run it. And what I see with a lot of companies that they come to EDB to say, okay, use a remote DBA service, or they come to Stormatics to say, hey, manage it for me because I want to run it on-prem for compliance reasons, for example. But I want my engineers to look at innovation. I don't want my engineers to keep the lights on. Please make sure that the lights stay on, that we have best practices, and I'll take my resources to go solve the next problem. That's something that I think a lot of people forget, that the more you own, the more you tie up resources, and the more projects you've done, the more this ball and chain, you have to drag it forward. And that's not where innovation happens. And I would highly advise people to think about that, the consequence of owning something like that. I found it much more effective to have a specialty company do that for you because there's a lot less risk. And as I said, you can focus your team on innovation, not growing, a team of 20, 30 DBAs somewhere in the basement, right?
Okay. So the last question is a very performance optimization focused one. So please bear with me. It's a mouthful as well. What is the perspective on using vacuum fill or PD repack to optimize Postgres table with frequent inserts and deletions? Specifically, how can one avoid the need to reserve double the storage space during a vacuum fill operation? From this person's experience, a table that grows to 45 GB after a week of heavy insert delete activity can be reduced to 34 GB after running a vacuum fill. However, to perform this operation, he needs to make sure that at least 90 GB of free space on the service is available. So,
That's a question for Umair.
yes, Umair.
Yeah, I think the way a Postgres concurrency is designed. Um, you can debate it. There are multiple databases implemented differently, um, but MVCC, the way it supports concurrency. In my experience, I've only seen it work really, really well with Postgres and in Oracle, nowhere else. Concurrency control and multi-version concurrency control. Postgres implements it in a unique way, and that unique way requires the removal of dead tuples as the snapshot becomes obsolete. And you do need to do a vacuum. Now, you don't necessarily need to do a vacuum full each time, right? Vacuum full is only required if you want to reclaim that space back to the OS. But if your database is going to use that space or recycle that space, a simple vacuum should be enough. You don't need to go for a vacuum full. But if your requirement is to give that space back to the OS, well, it's one of the designs that it makes Postgres what it is. So,
but I would also,
I
think Umair, you're absolutely right. This shouldn't happen. Like, if I was there, I would say, okay, show me what you're doing with vacuum. I hope you're not turning vacuum off all week and then running vacuum full over the weekend, because we've seen that. Because you have customers who say, oh yeah, but that gives me 2% more performance. Okay. But it actually causes a huge problem, because the performance gain disappears almost immediately, because the data that you load from disk is also now becoming significantly bigger, right? So the performance gain that you saw in the first couple of minutes is disappearing almost immediately. So I would really wonder why that is the case. And I would also want to look at the queries to say, okay, how can you produce that? I mean, because in that model, you would consistently update tuples, right? And somehow the space that vacuum itself would free up inside the table doesn't appear to get reused. That doesn't, like there's something I don't understand. This shouldn't happen, and I would really look first at tuning vacuum properly so that this can be avoided. And then PG repack, and Umair, please chime in, but I've recently heard a lot of good things about PG Squeeze as a tool that should also be considered.
Yeah. Now, in place, reclaiming of space, definitely, absolutely go for it. Vacuum full. I heard a very interesting analogy. Somebody made it, saying that vacuum full is like, your house is dirty, and instead of cleaning it up, you tear it down and you build a new house. Yeah, you don't do that, right? So yeah, I'd be very careful in using vacuum full. Configuring vacuum to be effective, it not only saves space and reduces load, also understand that vacuum comes along with analyze, which updates statistics of the database and helps the query planner do its job better. So it's critically important to ensure that vacuum is running correctly. And if it is running correctly, there's going to be an extreme edge case that would require a vacuum full. Otherwise, you should be good.
Yeah.
All right, thank you. So this actually concludes our Q&A session, and let's call it a day. Thank you all for being with us today, and a big thank you to Marc and Umair for such an insightful discussion. If you have, folks, any follow-up questions or you would like to explore anything we've touched upon today, feel free to reach out to Team Stormatics or the speakers directly via their LinkedIn. We appreciate your time and look forward to connecting again soon. Goodbye.
Thank you, Annie. Thank you, Marc. Take care.